In this video, we're going to start looking at continuity at a point. A function is continuous at a point C, and that's just some random value of x, when three conditions are met. The function value at that specific location is defined. The limit as you approach that number from left and right exists, and the limit as x approaches that number is equal to f of that number. The continuity on an open interval, a function is continuous on an open interval when the function is continuous at every point or each point in the interval. A function that's continuous on the entire real number line is everywhere continuous. Use the graph to find the limit. We have a cubic graph, decreases, has a turning point at 1, -3, increases, has another turning point, and then decreases. Our specific value of c for this example is c equals 1. As we look over here to the right side of the screen, the limit as x approaches 1 from the right. A superscript of a plus sign means approach from the right. I've noted that here on the graph. As you follow the function and close in on 1 from the right side, the y value is -3. As you close in from the left side, you'll see a superscript of a minus sign. Follow your graph towards x equals 1 from the left side, and note from the previous videos we're going to have a head-on collision. This function is also specifically defined at 1, the point 1, -3. So this graph is continuous at c equals 1. If your left and right limits are equal, then your limit as you approach the value overall will be equal. The function is also defined there, and so we're continuous at c equals 1. This is an absolute value function. Note at its vertex you have a hollow point, but above it's defined with a y value of 7. As we approach -4 from the left side, we're approaching the y value of 4. As we approach -4 from the right side, we're also approaching a y value of 4. Those one-sided limits are equal to 4. Both of them are equal to 4. And since they're the same, our overall limit is equal to 4. However, because this graph is not defined at -4, at the limit value of +4, it's defined as 7. Since -4 is not defined, this graph is not continuous at the x value of -4. It is defined at -4, but its function value is 7, which is different than the 4 that we calculated in our limits.